Okay, welcome to 202X, and a special welcome to all the 201X graduates, and I hope I'm going to have a chance to meet many of you again online and catch up on the forum and see how you have been doing, and then go on again together on this journey. So we're going to build on what we learned in 201X, and we're going to continue our journey in structural mechanics. As you know, in 201X, we started with very simple structures composed of individual structural elements. So we looked at just single bars in axial loading, at single shafts in torsion, and single beams in bending. And we learned how to predict the behavior of these structures for the special case in which these structures were composed of linear elastic material. So what we're going to do is build up from that. So we're going to go into 202. And in 202, we're going to do a number of things. So first of all, instead of looking at individual, one bar, one shaft, one beam, we're going to look at structures which are composed of assemblages of structural elements. So we're going to look at assemblages. So for instance, we may have a structure, say, that is composed of one beam loaded by some force. But then the beam would also be supported by another structural element. Say that I'm going to put here a little bar, and like that. And this bar is in axial loading, while the beam is in bending. And we're going to learn how to predict the structural response of an assemblage of this kind. So for instance, we can consider, instead of a single shaft, we can consider two shafts connected by gears, and we're going to learn how to predict the response of a structure like that. The other big thing that we're going to do and change from 201 is that while in 201 we were only looking at linear elastic constitutive response, in terms of constitutive response, constitutive of the material, again, we're going to look at structures which are elastic, but we're also going to look at effects of thermal strains. So this is effect of thermal expansion, what happens if you heat up the material. We're also going to look at the material behavior, which is elastic plastic. And you have experience of these things in your own life. For instance, if you take a paper clip and you bend it, and you permanently deform the material, so when you let go, the shape of the paper clip has changed. What you have done is you have imposed plastic deformation on the paper clip. And so this is something you see every day in your life, and we're going to learn how to predict structural response if the material behaves as an elastic plastic material. We're also going to look at viscoelastic response, viscoelastic. So viscoelastic response is a response which is time dependent. Again, you have experience of this every day in your life. Say, for instance, you load a shelf, a plastic shelf with a bunch of books on top of it, and then heavy books on the shelf. You know that after time, the shelf is going to sag a little bit in the middle. It's going to continue sagging more and more with time, especially if it's like a plastic shelf or not a very, robust shelf. It's going to sag over time. And this behavior, as you see, happens more and more with time. So it's a behavior which is time dependent and can be modeled through a material model which is viscoelastic. So we're going to learn how to treat all these different material responses for assemblages of materials in which each individual part of the material behaves in axial loading, torsion, and bending. We're also going to look at energy methods, which are alternative ways to solve structural problems in which you solve the problem by look at the problem from an energy perspective. Is the structural mechanics equivalent of Lagrangian methods for dynamics? So we're going to look at energy methods, and we're going to look at multi-axial stress strain So we're going to look at structure in which the stress-strain state in the structure is multi-axial in nature. We're going to look at things like pressure vessels and other kind of things that allow us to look at multi-axial stress-strain states and predict failure for this kind of structure and things like that. So I should tell you that this summer we're doing 202X Part 1. So Part 1, which is what we're going to do this summer together, is up to here. So we're going to look at assemblages of structural elements, structure composed of multiple elements, and we're going to look at the behavior of these structures for this kind of constitutive responses. Then Part 2, which is this part over here, we're going to do next year, next summer probably. Okay, so as I was saying, all these things is going to build on what we have learned in 201X. So if you're a 201X graduate, then you should be okay. If you're just jumping in right now in 202X, then probably I hope you have some foundation in structural mechanics. But to help you both the 201X graduates and people jumping in at this point, I've prepared this first week is just a preliminary week in which I've assembled all the material for 201 for axial loading. Because what we're going to do is, as we start our 202 journey, we're going to start simple. So we're going to start learning all this new stuff for structures in which you only have bars in axial loading. So in the review material, there's going to be the 201 material for axial loading. And also, I should warn you that there's going to be a little bit extra complication for math, because when we start dealing with viscoelastic materials, there is time. There is time as one of the variables. So some of the equations will be differential equations. So I don't want to get freaked out or be scared, because the kind of differential equations that we're going to do for viscoelastic material are very simple, first order, constant coefficient, differential equation, linear, with constant right-hand side. So this is the simplest possible kind of differential equation. Because I'm not sure about what is your background in math, what I'll do is I'll make a little video that explains how to solve this kind of differential equations, maybe a couple of exercises so that you can practice and so that you can start with some confidence. So it's really important that you review the 201 material this week, that you strengthen up what is your understanding of differential equations of this kind, so that you're ready to get our work done next week. So at this point, I'm excited to get started. We're going to build on what we know. You're going to learn new skills, and we're going to have fun. So as always, ask questions on the forum. I'm going to be on the forum all the time. I'm going to answer all your questions, and I hope we're going to get fun. Okay, welcome.